So I want you guys to you're okay. I missed this lesson. But I will try by all means so that I cover the most of this lesson. Uh, Today I'll just talk about uh where we talk about the alkanes. Alkanes. I asked you to read about them before to read about these alkanes and so the fundamental organic structures. You may zoom this video. So the fundamental organic structures the fundamental organic structures the fundamental organic. So in this chapter we are going to talk about the fundamental structures of organic compounds, the the categorization of drawing organic structures, functional groups, and the nomenclature. We need to know that organic compounds are compounds which contain a carbon element. They contain carbon elements. So they range from simple organic compounds, like they have a range. They can be simple organic compounds, and these simple organic compounds are hydrocarbons. Hydrocarbons, these are organic compounds which you have hydrogen and carbon. You have hydrogen and carbon. These are hydrocarbons. So hydrocarbons they have groups. Uh, group of- But in this in this chem 102, we're going to talk about the alkene and alkyne. And to draw their structures and to know them, these we are not going to talk about the aromatic compounds. The aromatic compounds are these are benzene. I hope you heard about benzene. Benzene is a six ring structure with resonance. It has resonance. We are going to just I'm going to show you benzene, but I will not talk about benzene. Don't read anything about benzene. You do benzene at Chem 232. Chem 232. 232. And also at the lab of Chem 234. Next, when you're doing year two in courses such as chemistry, in pharmacy, and other courses, but not this one. So the functional groups, you find that these are just specific, they are common and specific arrangement of atoms, usually the heteroatoms, atoms other than carbon and hydrogen. So these are just arrangement of other common or hetero atom. These are uh, hetero means different. So different atoms. These are just different atoms. So they make functional groups. The functional groups, you should know that when there is a halogen on a structure, when there is CH, Cl, that is a haloalkane, yeah, a halide. That's a halide. When there is COOH, that's an carboxylic acid. When there is CO in the middle, that's a ketone. And when there is COH at the end, when the O is alone, that becomes our aldehyde. And we have others that are found in between, others that are found in the between, like is a connection, and other is a connection. And there are some ethers that also there, but you are going to be learning about. But these functional groups, you need to know how to name using them only. But I'm not going to go into details about them in Chem 102. We're going to go details in another chemistry. So nowadays we are interested in the hydrocarbons. So the hydrocarbons, you find that we don't have these issues of functional groups. And most of the time, this you are talking about alkane and cycloalkane. And from five, we've introduced this new mechanism of cycloalkane. So cycloalkanes, these are alkanes in a ring or in a circle. You find them that they're in a circle. They are called the cycloalkanes. So the word ane means single bond. Ane means single bond. Anything that's with the word ane, it means a single bond. When I say alkane, cycloalkane, because there's A-N-E, it means a single bond. And we don't say a single bond just naturally. We say carbon-carbon single bond. Carbon-carbon, excuse me, carbon-carbon single bond. So we are talking about this one, that they have a carbon-carbon single bond. So that's why we say they are called alkane, cycloalkanes. So there are two alkanes now I talk about. These are alkanes which have single bonds, but they're in a form of a circle. They're in a form of a circle. So they have a single bond where they're in a form of a circle. We talk about alkene and cycloalkene. Alkene, the word E-N-E there, it means what? Double bond. Not just a double bond, but a carbon-carbon double bond. And they can be, that double bond can be one or can be more than one. It can be two, three, four, five, but it should contain a double bond. It should contain a double, to contain a double bond. You contain a double, they contain a double bond. So alkyne, they just contain a triple bond. Alkyne, they contain a triple bond. So for in case of multiple choice, let us just explain what are aromatic compounds. Aromatic compounds, they contain benzene, ring, and its derivatives. Derivatives of benzene, a phenol. A phenol is a benzene. A benzene is a hexagonal structure. Just draw a hexagonal structure now, a hexagon. After you draw a hexagon there, just put a circle inside the hexagon. That's a benzene. That's a benzene. And when you put an OH on top of that benzene, it becomes a phenol. That we have a phenol, we have amine, we have amide, that we phenyl, that lot of benzene. There are a lot of benzene. So we talk, these are aromatic compounds. So anything is, you should make sure that it's a hexagon, hexa, 6 sides. If it's more than a 6 sides, it's not benzene. It can't happen. There's a property of organic compounds whereby when they reach six, they become so special, so special. But there's an objective which we need to address now. Why is carbon special? Why is carbon special? A carbon atom is special because of the ability to form chains, catenation. So we are going to look. So don't alkanes and alkenes. We have them in more shapes. We have them in more shapes because alkane, and alkanes, we have them in more shape because of the catenation property of carbon. Carbon can exist in more shapes and it can rearrange itself. So carbon atoms, it can make 4 bonds. It is tetracovalent. 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 Tetracovalent means that carbon can bond up to 4. So carbon can bond up to 4. So make sure that when you are doing the structures of alkanes and alkenes and alkynes, make sure that carbon, it has 4 arrows. 4 arrows coming out of it. For it to be full, it needs to have 4 arrows. So in those models, you're given models at University of Botswana. Those models, just check those models. Check a black atom in a model. That will be a carbon. So you see that there are 4 four things coming out of those carbon. And we're going to do them here. I'm going to give you experiments where you do models and you take a picture and you send to me doing a model. I hope you all have models. So the alkane, alkyne, and aromatic rings are hydrocarbons and functional groups because of the presence of multiple bonds, even without hetero atoms. So these alkane and alkanes, they can sometimes appear without them having having heteroatoms. Heteroatoms. These are atoms. The heteroatoms. These are atoms apart from carbon and hydrogen. And most of these carbons are we have nitrogen there. You make an amide, and we have oxygen. These are so we need to know that uh the structures and different structure formulas. We the structures of the alkane, the structures of the alkane. The formula of alkane is Cn. The formula of alkane is Cn H2n plus 2. Cn H2n plus 2. Cn H2n plus 2. So when you have one carbon is a methane, two carbon ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. But we just stop there, because if you ask you when you say how many carbons are there, what is the condensed structure? We have a formula. In a condensed structure. To draw a condensed structure, I will just make a video on how you draw condensed structures. You remind me on that one. Maybe tomorrow I should make a video on calculations of physics, and also make a video on calculations of these condensed structures. You need to know how to name them. That sources, these alkanes, that sources, that primary source they are found in natural gas and in petroleum. These are the sources of this alkane. And the natural gas contains only methane. Methane, which burns into blue flame. Go and take your gas stove now and just open it. You see that there's a blue flame which is burning. That would be our methane. These are just separated into fractions, and alkanes of similar number of atoms, propane, and all those kinds of things. We just use our knowledge of senior secondary school here. It still apply, and it is relevant. But today our main focus, you should know how to name these compounds, especially to name the alkynes, the alkanes, and to draw their condensed structures, and also to know how to use a line formula, and also a 3D structure formula, and also a 3D structure formula, and also a 3D structure formula. Don't worry about them. We'll look at them deeply. We'll look at them deeply. But for now, let's just look at the structures. The structures which we have. We have a structure called the Kikol structure. But this is just a structure we used to draw. You see their structure, a methane, they just the arrows, these are there. So this is an example of a Kikos structure. And after Kikos structure, we have another structure called the condensed structure. The condensed structure, let us look at the propane. That propane at the top, which is in Kikos structure. And let us look at the propane, which is in condensed structure. Look at those on those propane. So you see that in Kikos, I mean in figure 2.1a, there at the top, in Kikos structure, you see that there is CH8, like in a form of a map. In condensed structure, you just take that C How many C's are there? There are 3 C's in propane. So 1, 2, 3. So you take the 3, you sum up the number of hydrogen. So it is going to be CH3 there, CH2 there. Agree. Look at the first carbon in the equal structure from the left. The first carbon in equal structure from the left. You see that there's a C there. There are 3 hydrogen. So when you go to condensed structure, you just write CH3. Look at the carbon in the middle. There are 2 H's. You just write CH2. So that's what you call condensed structure. That is what you call condensed structure. But sometimes the condensed structure, you can just remove those arrows. You can just remove those arrows, like in 2,2-dimethyl pentane, 2,2-dimethyl pentane. You see that there's some arrows there. You can just remove those arrows. Just remove those arrows. So the other way of writing it, 2,2-dimethyl pentane. You see that there are 2 CH3 surrounding the second carbon from the left. The CH3 the CH3 kotas. O khona kola CH3 was bracket 2. Khona kola CH3 was a bracket 2. Kola CH3 bracket 2. That's that. So we are going to present these organic compounds. You can present them in equal structure. We can also present them in condensed structure, or we can also present them in short line structure formula. Short line structure formula, we are going to use a principle of a zigzag principle. And those principles, just read those principles, but we don't like it's a skill. Its application is so simple. Don't worry about it. Like propane. So it represents carbon. It represents carbon. So look at the propane. It is 1, 2, 3. Because there's a carbon lanta line, carbon number 3 there. It's carbon. Look at 2-methyl propane. Or 2-methyl propane. 2-methyl propane. So how many carbons are there in 2-methyl propane? There are 1. Look at the chemical structure. In 2-methyl propane, there are 1, 2, 3, 4 carbons. Look at those 2-methyl propane on short line structure. There is a carbon. Even that center. That center. There's a carbon. Yes. So in short line structure, we don't represent the carbon. The carbon, we don't care about it. The hydrogen. Corner, why it's hydrogen automatically. But because CH3 because is a dry, is a functional, is a sort of a functional group there for that case. But CH3, 2-methyl propyne. But other hetero atoms in short line structure, you don't just leave them like that. You make sure that you indicate them, you write them down, you draw them, because so there are conditions but how to write line structure also sipe carbon I will know that is hydrogen that we call it a short line structures. But there's some structures called the perspective formula 3D structure. The perspective formula 3D structure, I will make a short lesson explaining them, because they are so need to know them. But for you to know them, you need to study what you call hybridization. I just skipped hybridization because I wanted you to get the momentum of organic first. Because if I was to start with hybridization, I will just discourage you because it is much difficult. So there's SP1 hybridization, SP2 hybridization, and SP3 hybridization. So SP1 hybridization is the hybridization of a single bond. So alkenes, they are SP1. Alkenes, they are SP2. And alkynes, they are SP3 hybridized. We're going to talk about the issue of hybridization. So those small arrows, they mean is perspective, how we look at the atoms. I hope you will be doing this when you guys will be holding your models, and we do that. I'll show you from a model that this atoms is looking towards you, and this atom is away from you. And when it is towards you, it is in this format. When it is away from you, it is this format. But these are just the formats of what we need to know. So we are going to present these organic compounds into three formats. It's either you use the Kiku's, or use the condensed formula, or use a short line formula structures, or you use a perspective. But is this atom away from me, or is this atoms towards me? We have the other objective of constitutional isomers. Methane, ethane, and propane, they have only one way of carbon arrangement. As the number of carbon increases to 4 carbons, there are two ways for which the carbon atoms to be connected. One in a straight line and the other in a branch. So constitutional isomers, they differ into structure. They are like structural isomers. These are isomers. What are isomers? Isomers, these are substances with the same molecular formula. Molecular formula example, when something it is C4H10, you know how to do the molecular formula. For you to do the molecular formula, you count the elements which are there. When there's carbon, you say carbon. How many carbons are there? 5. When there's hydrogen, say hydrogen. How many hydrogen there? 12. So these are called the molecular formulas. You are just interested on the molecules. You are just interested on the molecules. So when you are just interested on the molecules, that is what you call a molecular formula. A molecular formula is a formula whereby you are just being interested. You are interested on the molecule. But there are different kinds of isomers. We have a stereo isomers. We are going to look at enoshimers. Enoshimers. Where are these mirrors? Can you rotate these ones? There are some isomers where you look at geometric isomers. And we are going to do geometric isomers. Is this cis? Is this trans? Is it Z? Is this E? Isomers, E isomers, Z isomers, cis or trans isomers. We are going to look about them. And in the bio 111, we talked about these kinds of isomers, where we said that this carbohydrate is in this kind of an isomer. This is a D and this is an L isomer. This is a D glucose, this is an L glucose. This is a cis glucose, this is a trans glucose. We looked about that. And we constitutional isomers, they differ into structure. They just differ into structure. How do you see that these things are isomers? You make sure that you should count the number of molecules which they are there. After counting the number of molecules which are there, we need to make sure that the number of molecules for every structure which is drawn is the same. If the number of molecules per every structure drawn is the same, it means those things are isomers. Those things are isomers. But we can't end today without us what should you do today? Yeah, we need to let us recognize the degree of carbon. Is the carbon a first degree carbon? Is the carbon a second degree carbon? Is the carbon a third degree carbon, or a carbon a 4 degree carbon? So let us learn more about those things. So a first degree carbon is called a primary carbon. A second degree carbon is called a secondary carbon. And a third degree carbon is called a tertiary carbon. And a 4 degree carbon is called a quaternary carbon. So a primary carbon is a carbon which is directly attached to one carbon. Like, is attached to one carbon. Let's look at the issue of a methane. A methane is attached only to one carbon. Like, that carbon is attached to not attached to anything, not attached to anything. So that carbon does not have a degree. But let us look at the structure of an ethane. Just draw the structure of an ethane there. It's C. So those carbons are second. These are first degree carbons because they are attached to what? To one carbon. Look at the structure of propene. Propene is 3 carbon. It means that the carbon in the center, is a second degree carbon. Why are we saying that the carbon in the center is a second degree carbon? It's because it is attached. It is attached to one or to a single carbon. So the carbon attached to a single carbon is called, the carbon attached to a single carbon is called a first to two dot. So the issue of isomers, we are going to explain more about those issues. But today I wanted you guys to know these secrets of organic chemistry. But I will also make a video of nomenclature of alkanes in the evening, and I'll post it in the morning. Alkanes, how to name them, and also make a video of alkanes. Make a videos, and I'll just post the video so that you guys are able to appreciate the content. I hope if you have any questions, you may ask me.